Okay, today we're going to start with the very beginning of probability in Chapter 6. There's a lot of vocabulary in this chapter, the first being random phenomenon, which is a situation in which we know what outcomes could happen, but we don't know which particular outcome did or will happen, like rolling a die or flipping a coin. And the probability is the probability of something happening is it happening over the long run, the relative frequency of that happening. Relative frequency means percentages. The sample space is the set of all individual possible outcomes. We have different events that are subsets of that sample space. Relative frequency, again, is percentages. Trials is how often things happen. How often you flip the coin, draw a die, or roll a card, draw a card, roll a die. And then this probability model, or this probability distribution at the bottom, is a chart of all these different probabilities. Okay, so we're going to look at the sample space here of rolling a die. If we roll a die, there are 6 different outcomes. They are 1, 2, 3, 4, 5, and 6. And you notice we put them in little brackets, and those are each individual outcomes. Now, events are subsets of that sample space. So A, rolling a 3 is an event. Now, look here, this is the probability of that event. So what is the probability of A? What is the probability of rolling a 3? That would be 1 out of 6. 1, 3 out of the 6 options. B, what is the probability of rolling an odd? Well, that would be rolling a 1, a 3, or a 5. So that would be 3 out of 6, which reduces to 1/2, but we don't worry too much about reducing in probability because 3 out of 6 means more to us. 3 out of 6 means there's 3 ways to get an odd out of 6 total. And then event C is rolling a number greater than 4. That would be rolling a 5 or a 6, so that's 2 out of 6. So if we rolled the dice 600 times, what type of distribution would we see? Well, we would have the 6 outcomes, 1, 2, 3, 4, 5, 6, and they would all show up the same amount of times, approximately, all about 100 times. So we would have about 100, maybe a little bit more, maybe a little bit less, but they would all be right about at 100. And what do we call this type of distribution? This would be uniform, straight across. So down here we have the probability model, and all that does is show the different probabilities for each individual outcome of the sample space. So what is the probability of rolling a 1? That's 1/6. Rolling a 2, 1/6. And all of these are 1/6, of course. One thing to note here is this total always is 1 because it's each individual thing happening. Okay, so now I want you to go ahead on your own, is pause it and come up with the similar concepts here for flipping 2 coins. So this is flipping 2 coins at a time. So go ahead and pause now and get started on that. Here we have the multiplication principle. If we can do one task in A number of ways and a second task in B number of ways, then you can do both in a total of A times B number of ways. More vocabulary: with replacement, without replacement. That usually refers to a deck of cards. With replacement, it means you take one card, record it, put it back, shuffle, and take it again. Without replacement means you set it aside. We do that with cards, marbles, balls that we're pulling out of a box, anything like that. So here's an example of that. So multiplication principle, with and without replacement. So what is the total number of outcomes of flipping 4 coins? And it doesn't matter if you're talking about doing them all at once or doing one coin 4 different times. So that is the multiplication principle. So the first outcome, there's 4 scenarios. This has heads or tails, so there's 2. This one has heads or tails, this one has heads or tails, and this one has heads or tails. 2 times 2 times 2 times 2 is 16. There are 16 different outcomes when you're flipping 4 coins. For example, one of those outcomes we're talking about we could have heads, heads, tails, heads, which would be something different than heads, tails, heads, heads. There's 16 different outcomes like that. Uh-oh. Okay, so now we're going to draw a random digit from pieces of paper and a hat. So we've got digits 0 through 9, so 10 different digits. How many different 3-digit numbers can you make with replacement? So we draw a slip of paper, we record the number, we put it back in, we shake up the hat, and we do it again. So there are 3 spots. With replacement, how many different slips of paper are there? There are 10. Put it back in, shake the hat back up, the next slip you draw, there are 10. Put it back in, shake the hat back up, there are another 10. For a total of 1,000.
Maddie Russell to the counseling office.
Hey, Maddie Russell. Okay, so there are 1,000 ways you can do that. So without replacement, still 3 different numbers. Pull out the first piece of paper. There are 10 different possibilities for what that could be, but this time you're going to set it aside. Now how many slips of paper are in there? There are 9. Pull one out, set that aside, and now there are 8. So without replacement, which means not duplicating numbers, there are 720 possibilities. Oh my gosh. Okay, tree diagrams is another way just to organize data. So here we have flipping a coin and rolling a die. So flipping a coin, we could have heads or tails, and then with that head, we could have a die that's 1, 2, 3, 4, 5, 6. With the tails, we could have 1, 2, 3, 4, 5, 6. So different outcomes here would be heads and a 1, heads and a 2. So how many events are there? There are 12. What is the probability of getting a tail? That would be these 6. So 6 out of 12, or 1/2. There's 1/2 is the probability for getting a tails. Even would be these options here, and there are 6 out of 12 for that also. So again, what's the probability of getting an even? That's also 1/2. What's the probability of getting a heads and a 1? There's 1 out of 12 ways, and a heads and an even would be 1, 2, 3 out of 12.
Rashmi Patel, please report.
This slide here is just a standard deck of cards. Just so that if you're confused about cards or whatever, you can always refer back to this. One thing that might be hard to see on the video here is how many face cards are there. This is always something confusing for people that actually play cards, because sometimes a 10 has the same value of a face card, or an ace is a really good card like a face card. However, there are certain cards with faces on them, which makes these 12 face cards. So there are 12 face cards because those are the ones that have faces on them. Okay, go ahead and pause here. I want you to go through and calculate some probabilities for this. Talk about the sample space. We're talking about 4 glass ornaments here, but you were given specific probabilities instead of knowing them on your own. And that's it. We are finished, and we will go through these in class, and I hope you enjoyed it.